This is Algebra 1, Term 6, Lesson 2, Data Distributions. We'll first start with the Desmos classroom activity, and then we'll do a quick GeoGebra task where they create their own dot plots. And then finally, we'll explore mammals using a resource from U-Cubed. So let's get started. The Desmos activity is pretty short, but there is quite a few screens here where they're going to have to calculate the mean and the median for a set of data, and there's quite a few points for them to type in. So because of that, they will need a little bit of time to get that done. There are a total of 10 screens. On the first screen, they're simply going to choose one of the dot plots and explain what makes that dot plot different from all the rest. They all have unique characteristics, so really any answer will be fine here. The next screen talks about symmetry. One of these graphs is definitely not symmetric. So the one that is most skewed they should choose and explain what makes it not symmetric. Here they have data that is definitely skewed, and they're given some terminology, some vocabulary here. And one way I help kids remember which way it's skewed is think of pulling the tail of a cat. So I have these cutesy little icons up here as a clue. When we pull the tail of the cat to the left, the data is skewed to the left. So they will calculate the mean and the median for the data. They will use this calculator icon, and they can click over here and just create their list like they did in the calculator yesterday. And then they can come down here and type MEAN, mean, and put the name of their list in parentheses, and it will do it for them. So basically they're reviewing what they learned yesterday. They should notice there's a relationship between the mean and the median. They're comparing them. Same here. They're given a symmetric distribution. This is also called a normal distribution. We don't really use that. They will not be assessed on that, but that is a statistical term where it follows the bell curve. They will calculate the mean and the median for the data, so they will simply type these numbers that they see here on this number line into the calculator, get the mean and the median, and then compare them. On this screen, they're given dot plots and histograms, and they're simply going to sort them into symmetric, skewed left, and skewed right. It is self-checking. Here's another graph. Is this one skewed left, right, or symmetric? Find the mean, find the median. Now I want them to draw on the graph, so this has the sketching tools, a vertical line to represent the mean, and then use another color to draw a vertical line to represent the median. And what do they notice? When it says what is the distribution, that simply means state whether the data is skewed left, skewed right, or symmetric. Here they're going to do it again. They're going to calculate the mean and the median. They're going to draw in the graph, and they're going to identify the distribution and notice the relationship between the mean and the median. Now, if they don't get it, if they still aren't getting it, and some will, I'd say most of your kids are going to notice that, but some don't. And so I'm giving them an example that almost every kid understands, and that is their grade. So let's say these are all your grades, and I just listed out some grades, and all of a sudden you make a 100 on a test. What will that do to your average, which is the mean? And hopefully they know that's going to pull up their average. But what does that do to the median? Well, you'll notice in the data set there are a whole bunch of 80s, and 80 is actually the median. So putting an extra number at the end is not really going to change that. So the median was not affected, and that's kind of what we're trying to get at here. Then they're going to choose 3 statements that are true out of this list. So here we're talking about an outlier can pull or skew the data to one side or the other. It's actually going to pull your average higher or your mean higher. It does not impact the median. So they're learning that the median is a more stable measure of center when you have skewed data, so we tend to use that. They're going to sort these again into different distributions, but they also have included here the mean is greater than the median, the mean is equal to the median, and the mean is less than the median. So using what they just learned on the previous 2 or 3 slides, they're going to apply that here with these different types of distributions. Now we're going to go back to our slides and do a GeoGebra task. So here we're going to explore measures of center again, and they're being told to create a dot plot so that the mean is greater than the median. So they will click this link to open GeoGebra. and they simply are going to pull these X's over here onto this graph, and they can arrange them however they want. They can stack them up, or they can, they don't have to use the numbers that are on the graph. They can actually go between them, like I've got a 27 right there. Maybe I want another 27. So just tell them to grab these points and place them onto this number line to create a dot plot. Once they've done that, they're going to click on mean. They're going to click on median. They don't have to click on mode. They can if they want to, but that's not required. So the instructions on the slide are asking them to create the dot plot so that the mean is greater than the median. So they will have that showing in their graph, and then they need to describe the distribution. Is it skewed left, skewed right, or symmetric? And then they will insert images. Now they're going to have all three possibilities here. So the next slide will say, now make the mean less than the median. And then the last one, make the mean equal to the median. There should be a variety of different graphs here, and this would be a good candidate for the portfolio. So as students are picking things to put into their portfolio, remember one of the requirements is that it would be something unique to them, not something that every student in the class did. So since they're creating their very own graphs, this would be a good possibility. All right, the last thing we're going to do is something I found from U-Cubed, and that is an exploration using an app that they have created. So the students will simply click here, and it's going to open up CodeApp. Okay, and it's basically this wonderful little application that lets them explore mammals. Now the cool thing about this is they can't really mess it up. They can always undo right here whatever they've done. But tell them to click over here and they can choose different things. They can click over here and choose to look at different things. And if they click here, it will create a new graph. And then they can click down here and change that to height. Or maybe they want to change that to lifespan. Or maybe they'd rather change that to speed. Okay, so they have lots of possibilities. So they're going to create one of these graphs, and that's what they're going to put onto their slide. Now we'll let you know if they'll drag here. They can make that thing way bigger than it is. Now it's important they not click on this one because it's going to give them an y-axis, and we're doing single variable statistics. We want to kind of stick with one axis. They'll paste their graph onto their slide, and then they will answer a question. Why is this data skewed? Which animals are causing the data to be skewed? So they can actually look at the data and make sense of it, hopefully, and figure out which animals are skewing the data to the right. The next one they're going to use, do another graph and create one that is symmetric. And none of these graphs are super symmetric, but a couple are pretty close to symmetric. So tell them to choose one that's the most symmetric and then put that on the graph. And why do you think it's symmetric? What's special about this graph that makes it symmetric when a lot of them are skewed? So what made those different? And that is all we have for that exploration. So that concludes our data distributions lesson. Next time we'll get into measures of center and measures of spread. Y'all have a great day.